G. Zero point zero two. Okay, so then take log. I don't know.
So we have to work in reverse. X is t, so that's the same. That's the easiest thing. In this one, what do you know when x is 0?
B is 1.
Yeah, so t is 0, b will be 1. And so what do you know about the value of k?
G equals K.
And so what would we be able to figure out k from that?
I don't know.
Is k minus 0.2215 basically the initial value? When x is 0, t is 0, and when t is 0, that is k.
Fair.
I think it might be. So I think this is working in reverse. Let's see. If we did this as g equals kb to the t, and we log both sides. So log g is the y. Log kb to the t. What can we do there?
You can separate it.
Yeah.
So you get log K plus T log B.
Would it be plus log? Yeah, t log b. Yeah.
Yeah.
B. So log g was the y. Log k was the constant. Okay. So can we use that to find stuff?
Log B equals 0.0792.
Let's see. So t log b, when t is 0, yeah, so c, I think the constant log k is equal to, yeah, I think it's log k is equal to the minus thing.
Mm-hmm.
And so you, so what is k?
I got 0.6.
Is that 10 to the minus 0.2215?
Yeah.
Okay. And how can we use that to get b?
I don't know.
Can we sub in another thing now that we know what k is? let's say when t is 3, g is that, and we could rearrange it to get b.
Oh yeah. So 1.04.
So I think it's log g, so it'd be log 1.04.
Uh, equals log 0.6.
Well, let's see. Oh, no, log k is minus 0.2215, isn't it? So you can just replace that whole thing with it, yeah.
B to the power of 3. So log 1.04 plus 0.2215 cube root that. So log plus. I got 0.6 again.
Okay, so 0.2215 plus log 1.04 all over 3, and then you do that 10 to the power of that answer. Is that what you did?
I didn't divide by 3.
Because this was 3 log b, it's t log b, and for the 1.04, the temperature is 3.
Oh, I cube rooted. Hang on.
So I might be the crazy one.
Which equation are you rearranging from?
So I did this one here. So log g, I did log 1.04.
Yeah.
Log k is minus 0.2215.
Yeah.
And t log b, I wrote 3 log b.
Yeah, so 0.0795, and then 10 to the power of that 1.2.
Okay. So 1.2, and so g equals 10 to the minus 0.2215 times b was
1.2.
1.2 to the power of t.
Mm-hmm.
Ooh, let's hope that's not very wrong. Okay, let's take a look. When t is 0, x is 0, y is that, log g is that, so that's 10 to the thing. So they just used 0.6, okay. Sub x is t, da 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 da. 0.6 times 1.2 to the power of t, so that's what we got.
Mm-hmm.
So maybe I should just use the decimal thing. G equals 0.6 times 1.2 to the t. So in general, I can never remember what way it works. Like there's two formats for it. I just log both sides and I just write it in the form of y equals mx plus c. It kind of naturally goes into y equals c plus mx, and then you can just find the c by matching those up and then sub in one value to find the m, or I suppose in this case the b. Any questions there?
Nope.
Good. I'm pretty surprised that was the correct answer. Let's see. So there's no exam questions here. Oh, there is. Alright, let's try it.
Okay, so in the form where y equals g and x equals t. So then log a equals 0.09, a equals 10 to the 0. 1.23, and then log g was y, so log 5.37. Log 5. What was even the question? Okay, yeah. Log 5.37 equals 0.09 plus 13 log b. Log b equals 0.049. So b is 10 to the power of that equals 1.12. A is what?
What was A?
1.23.
Yeah. And what did you get for B?
1.12.
Equals 1.12. There was a part B. Okay. How about B and C?
Good. Constant B. Constant B. B is the rate at which growth of a population increases.
Correct.
Something to do with temperature, as it goes up in temperature, something like that.
Yeah, so if it was the, basically it's the M. T is like the X. So it's like Y equals C plus XM. So it's just kind of the way we wrote it. Yeah, it's like the gradient, and so it's the rate of change for this stuff. Okay, and C.
If temperature was 35 degrees, it doesn't state it would be extrapolating because it doesn't say the data was 35 degrees.
Yes, so C, it's extrapolation, it's outside the data. Any questions there?
No.
So, and then B is the rate of growth, or whatever that was.
Mm-hmm.
Great. So that was that one. X a half or tick?
Tick.
Great. Measuring correlation. It's always between 1 or -1. Perfect positive, perfect negative. 0 is no correlation. You've got strong positive, weak positive. Strong negative, weak negative. This thing's going crazy. Okay. Let's try this one. Large data set time. How about this? Oops. Sorry.
State the meaning of NA in the table above. No data for that month.
Yeah, data not available for that day of the month or whatever. Yeah.
Calculate the PMCC for the remaining 8 days. I forgot how you do this. Let's have a look.
And do you have your graphical calculator?
Of course.
Okay. I've been getting better at it, but I've never done correlation with it.
I literally didn't know where it is.
It's got to be under stats, I think.
What's that?
What?
Nothing, I just saw something. Thought it would come in handy one day, but no. How to do that? Where is it? I wrote this down somewhere, I just don't know where. How to do it.
Let's see. So, day of the month.
Oh, here we go. Oh, wait, no. How do I do the freaking PMCC? Actually, okay. Put in the data. Four, 8, 7, 12, 3, 4, 7, 10, 13, 12, 19, 23, 33, 37, 10. We're deleting that one. Deleting that one. 10. It's 23. Okay, so you enter the data, you go into calc, reg, x, ax plus b. So, what was the question? PMCC, which one's that? Is that R?
What do you mean, sorry?
Which one's the PMCC? Is that R?
I believe it's R, 0.95. Let me just check, because I think it should be A plus BX. No, that's it, 0.9533. Okay. Are you able to do that in your calculator? Do you know how to do it?
Yeah.
Great. And C.
It's a strong positive correlation. With reference to the answer part B, comment on the suitability. What's a suitable? I don't know. I actually don't know.
Should we use linear regression? Should we model this as linear regression, given that we got strong positive correlation?
Yeah.
Yes. So it's a good model because we got strong positive correlation. If we got no correlation, then it wouldn't be a good model. And if we got strong negative, it would still be a good model. R is close to 1, so there is a strong positive correlation between X and Y. This means that the data points lie close to a straight line, so a linear regression model is suitable. There you go. Why would they do this to me? Alright. Exam time. If it will let me. How are we doing this one?
Oh my god, I can't bother to do that. Log 231 is 2.36. Log 41, 1.61, log 17, 1.23, log 7, 0.845, log 2 is 0.31. Calculate the PMCC for the coded data. Okay. 2.1, 1, 17, 17, 2.36, 1.1, 1.23, 0.85. Calc reg x axb r equals 0.862.
Did you get the PMCC?
Yeah, 0.862. Good.
Okay.
Because the PMCC is close to 1, therefore there's a strong positive correlation between the number of atoms that are radioactive
Mm-hmm.
at the time. Therefore, exponential model is suitable.
Excuse me. Therefore, they lie close to the line, and therefore an exponential model is a good fit, or whatever. Yep. Okay.
Yeah. Y equals 2.487 minus 0.320x. Find an expression for n in terms of n equals a, b, 2, where a and b are called. Y equals log n, so log n equals log 2.587 minus t log 0.320. So log 2.47 is a. So a equals, log a equals log 2.47. So 0.3957, so 0.3957. So a equals 2.487. Oh yeah, too bad, I already gave us that. Didn't do that. But if y is log n, so log 2.3, so 2.36 equals 2.487 minus 1 log. How have I just done? T log B. So 2.36 minus 2.487.
Isn't log A 2.487?
I thought log A was I'm gonna do this again because I've done something weird. Hang on. N equals AB to the power of T. So log N equals log A plus T log B. Log N was Y. Log A is 2.487. So A is 2.47. Oh, what?
306.9?
Yeah.
Yeah, I think so.
And then if log N is Y, so 2.36 minus 306.9
Bless you.
over x1 equals log B. So then 2.36 minus 3 divided by 1 equals minus 304.54. Where B equals... Wow, I got 0.
It's very close to 0, is it?
No, it's just 0.
No, I got 0 as well. So 0. So B is 0. That feels weird. So if B was 0...
0 to the power of T is 0.
So that couldn't be 0, could it? It wouldn't do anything. So this is question 4. This was a strong negative correlation, was it?
No, I got 0.86.
Did you do a correlation of T on log N?
No, I did N in log N.
No, T on log N, because T is like X and log N is like Y.
1, 2, 4, 5, and 7. XP minus 0.98.
So N was 307 roughly, that's what they said. They said B is 10 to the minus 0.320. Where are they getting that? So that's just the rate. Did they kind of help us? I kind of thought minus. So log B is the rate, and for this one the m is minus 0.320.
Mm-hmm.
But why did our way not work? See, this might be the other thing. I know there's two types. Trying to see if there was some extra thing that they got here. 3, 4. So that was that. So, so y equals that. Log n is y. So log n is equal to. So they just replaced y with log n, that with t. What did we do? We said log
N to n.
We did log a plus t log b. So that is log a, t log b. We'd no one to blame but ourselves, I think. Really, like log b absolutely matches up with that. So log n, I don't know where we went wrong. Log n is log a, and this is log a. Minus t log b. So this is t, this part is log b. So log b is minus 0.320. So 10 to the minus 3, 10 to the minus 0.320 is b. I think I just overcomplicated this somehow.
Okay.
Where did I go wrong? I wrote 1 log b. I wrote 1 log b. I was meant to write t log b. Okay. Any questions there? Sorry?
You put 1 because...
Oh, because I subbed it in.
Yeah.
So if I put 1 there as well, if I put 1, this is somehow different. There's some difference with this one. Let me just go back a sec. G equals AB to the T. I don't know where I went wrong here. I'll have to look at this more. G is equal to AB to the T. And G equals AB to the T. But did they give me the line of best fit? Yeah, they did. Alright, I'll look at that more another time. Where I went wrong there. Let's see, K5. Coded data. So K and N. Okay, let's try this one. Okay, how are we doing this one?
So we have width, mass, log W and log M. 3, 4, 6, 8, 11, 23, 40, 80, 147 and 265 log.
So I'm creating a table of values for this. I'm just doing log x from 3 to 11.
Okay.
2.4. So
62 log 1.602. I'm doing it the long way because I'm not that tech savvy.
Oh no, that's 5, is it? That's 5, sorry. 778.
Log 265 is 2.232, 2.42. Okay. Calculate the PMCC coefficient for the coded data. We use .9 watt 5. I can't read my writing.
Which one is it?
Log 8 0.903 0.903 and 1.04. 1.362, 1.602, 1.903, 2.167, 2.423. Reg x plus b r equals 0.99, depending if that's constant xn. Constant.
0.99?
Yeah. Calculate the where kxn, where kn close to 1, so suitable.
Yeah.
Something like that. Determine the values of k and n. So y equals log m. Where the frick did m come from? Oh, log m equals log k.
So that's y. So that log y. So that should be log m.
Plus n log w.
Let's see. So x is log w.
Oh, I got so cold.
You're cold.
100% freezing.
X is log w. It's the power of n. So does that mean it's k n log w? Is this where I went wrong with the previous one?
I just put log k plus n log w.
I just subbed in, so x is log w.
Yeah, I took a log of k as well.
Alright, go on, do it your way.
No.
Yeah,
Log m equals log k plus n log w. They haven't even given us a thing. They haven't even given us a thing.
It might be simultaneous equations, isn't it?
Probably. I really don't really want to do this.
There might be a way to cheat.
Using the calculator?
Yeah. What if we put in these? So you already have, if you put these in, W and M, that will give us an equation, won't it? Like y equals a plus bx type of thing.
So log m, so 1.36 equals... Why have you got two calculators? They do the same thing.
I don't know how to use your one for everything.
I'm not sure.
Okay, so menu. I'll try stats. Okay, so one list is 11. Oh. 8. 11. The other one is 23, 40, 80, 147, and 265.
Mm-hmm.
And so if we do, I think it's a calc, regression, x, and I don't know the difference, but this is the one I did the first time. R was like also 0.9876. That's for these two. So A is 30 and B is minus 82.86. So that could be like our equation of the line that we use.
Yeah.
I just want to see what happens if I change. So A is 30, B is minus 82.
Literally the same.
So it's just a different way of writing it. Okay. Okay, so I'll write it as y equals a plus bx. I don't know. Because that's kind of the way we have it, the x being at the second one. And a is the constant then. So minus 82.86 is the constant.
So k is minus 82.
Well, according to you, it's log k is equal to minus... But would that be 0 or something?
So 10 minus 82.864 equals... Whoa, that's no.
That's basically 0. So does that mean k is that?
Probably.
Ooh, okay. So
It's 3 marks, it shouldn't be that hard.
Yeah. So if that's k, then what is w? Sorry, what is n?
Just put them into the equation.
Okay.
And then rearrange.
Put it in. What do you get? So values. So R was like 0.9996.
Probably, yeah. Can't remember. How did they get 0.464?
Oh no. Our cheating thing didn't work. Hang on.
Maybe we should put the logs in and then we'll see what we got.
Okay, we should put the other one in.
Menu 2. Calc regression X.
So you already had those in.
0.464 and B is 1.88.
Snagged me.
So
And so, okay.
to be fair.
And so log m, so that's like y equals a plus bx.
Mm-hmm.
And so log m is equal to, so that's the constant 0.464 plus 1.88 log w, because x is like log w.
Yeah.
Wow. So that is absolutely cheating. So you just put in so the y equals a plus bx is
I didn't
4.
even tell you how to get 0.464 plus 1.88x. If I didn't already know, that wouldn't have been not been helpful.
No. It wasn't that easy. Hang on. So k, so now we're using this one. Yeah, so it's log.
It is easy. They just can put 10 to the all of
Yeah.
that.
Yeah, so log k is equal to that.
And then
So it was just a normal type, and you just had to get the equation yourself because you had it in your calculator. Yeah, of course, because the other two are exponential or something, whereas these two are the linear ones, and so this is the linear thing.
this sucks.
And so let's see. So that's 10 to that. That's that one. And then the log w. What was the n? How did they get that one? N was 1.88. N is 1.88, so that one's already done. Yes, n log w. X is log w? Yes, that's it. So y equals 0.464 plus 1.88x. So log y is equal to log m, and so log m is equal to 10 to the power of 0.464 plus 1.88, and x is log w. There you go. With reference to that, determine the values of k and n. So that's all they wanted. Yeah. Any questions there?
No.
Okay, so they didn't even want it written as an equation, just the values. All right. Okay. Yet another thing. Let's see this one. Product moment correlation is easy with reference, so that's easy. That's easy peasy. Large data set. State the meaning of TR.
I don't know. No rainfall?
It means it's short for trace, and so it's very close to 0, and so they just ignore it. Yeah. Calculate product moment correlation coefficient for the 7 days. How would you do that one, part B, for this?
Calculate the PFC for these 7 days. So they included. Did they include? I would have just ignored them if I'm honest. But
I think you would replace TR with 0, because they said 7 days. 1, 2, 3, 4, 5, 6, 7. So put in 0 for TR, and we'll see if it's the correct one.
okay. .2, 5, no, 0, 1.4, 4.4, 0, 0.2, 0.6, and then 5.2, 7.7, 5.6, 0.3, 5.1, and 0.8.9. X must be R equals minus 0.47.
Take a look.
473.
Yeah, R equals minus 0.473, treating TR values as 0. Yeah, so TR should be interpreted as a trace, which means a small amount. So just watch out for that. So that was correlation, x a half or tick?
Tick. Probably tick.
Okay. Yeah, how was that for you, Saba?
Good.
Anything in particular you want to do next time?
Just exam questions, I suppose.
Okay, from anywhere in particular?
No.
Okay, we'll just go through them. We'll just pick some. So that's what we've been doing, just those exam questions.
Yeah.
Any questions for me in general?
No. Wait, hang on. No.
Alright, well done, Saba. You did great. I look forward to chatting again next week.
Thank you. Bye.
Have a good week. Goodbye.
Bye.